Okay, so I wanted to film me doing a few problems. You only need to do numbers 1 through 4 tonight for homework. But I wanted to make sure you guys had a good foundation, especially first period. We didn't get to like really go over the examples. And I think having a heating curve will help you. Okay, so I'm going to do number 1 and number 2, and then you guys just need to try and attempt to do 3 and 4. Okay. Remember, I want to see your work. Okay, so number 1 says how much energy must be absorbed by 150 gram sample of ice at 0 degrees Celsius that melts and then warms to 25 degrees Celsius. So I think what's beneficial is if you do some sort of heating curve. So we have ice and it's melting, and we know that happens at 0 degrees Celsius. So we have our ice melting. And then that 150 gram sample of ice starts to warm to 25 degrees Celsius. Okay, so there's our heating curve. Sorry. There we go. Okay, so you can kind of see there's 2 parts to the graph. So you have to calculate your Q, your energy, for 2 different parts. This first part, which was our ice melting. And then for that ice that melted, it heated to 25 degrees Celsius, right? Liquid heated up. So there's 2 different things you're going to be calculating, okay? So the first one, you notice there's no change in temperature, and we're melting, so we're using Q equals M delta H of fusion. All right, and then for the second part, we have liquid water being heated up. There is a change in temperature, so we have Q equals MC delta T. All right, sorry, I want to make sure we have room. So we're going to plug in our information. Q, we have 150 grams of ice. The heat of fusion for water or ice, melting or freezing, is 334 joules per gram. Okay, so then you can find your Q value. $150 times 334. I'm not rounding anything yet. Then the second part, that heating, that liquid is heated, we have Q equals, we didn't lose any water, so we still have 150 grams of melted ice. So now it's water. Our specific heat for liquid water, because we are in the liquid state, it's 4.18 joules times grams times degrees Celsius times our change in temp, which is our final 25 degrees Celsius minus 0. All right, we're just going to multiply those across. So we have 150 times 4.18 times 25, and you get 15,675 joules. So if we want to know how much energy must be absorbed for this whole process to take place, we're just going to add them together. So this is definitely taking what we know to a higher level. I got my total energy, 65,775 joules, right? If we wanted to sig figs, 66,000 joules. Okay. So I'm going to do one more. Suppose I'm going to do number 2, so you really only have 2 homework problems tonight. Suppose in the icy hot lab that the burner transfers 325 kilojoules of energy to 450 grams of liquid water at 20 degrees Celsius. What mass of water must be boiled away? All right, so we got to think of this in 2 different parts. We have liquid water is going to start to boil. So we're at 20 degrees Celsius. And we should know water boils at 100 degrees Celsius. Okay, so we're going to do another heating curve so we can see what's happening. Help visualize. We have our liquid water is being heated, and then it's going to boil. Okay, so we have two things. We were at 20 degrees Celsius, water boils at 100. Right, so for step one, our water was heated up. And then we had step two, some of the water boils away. Okay, so for the first part, there's temperature change. So we're going to use Q equals MC delta T. Okay, and we have our mass. They told us we had 450 grams. We have liquid water, so our specific heat, 4.18 joules times degrees Celsius. And our change in temp, we're at 20 to 100. So 100 degrees Celsius final, 20 degrees Celsius. So we do that and we end up finding our value being 150,480 joules. Okay. The question is asking what mass of water, okay, would be boiled away. So the second part, our second equation, there is no change in temperature. So we're looking at Q equals M delta H. We're boiling away, so vaporization. So we want to know that mass. Okay, and we know that the burner transfers 325 kilojoules of energy to 450 grams of liquid water. So we know our total energy. Okay, so we know our Q total equals 325 kilojoules of energy, or 325,000 joules. So we know this was given in the problem. That's our total. We know it has that much energy just from spot one. So we can figure out the amount of energy that was used here. Okay, so we're going to do that first. We're going to go the Q total equals, right, Q1 plus Q2. Right, those two things, these two should equal that. So we have 325,000 joules equals 150,480 joules plus our second, right, this Q from what was happening when it was boiling away. So I'm going to solve for that. So we get our Q2 equals 174,520 joules. Okay, so now I can plug that in to my equation. I know my Q, 174,520 joules, equals my mass. And I know the delta H of vaporization for water is given to us, and that is 2,260 joules per gram. divide both sides by. So my mass equals 77 grams. Okay, so these are a lot more challenging. Two-step, you only need to do numbers 3 and 4 now, okay? Hopefully this helps.